Hello and welcome. Let's talk about a pattern that might feel all too familiar in your work life. Does this sound right? You spend your day in a constant state of reaction, putting out one fire after another, solving urgent problems, and responding to whatever the crisis of the moment happens to be. You work hard, you make constant adjustments, and you definitely keep things moving. And yet, the same types of issues just seem to pop up, again and again. This endless cycle of reactive problem solving is exhausting, and it often feels like you're just running in place, never truly getting ahead of the curve. This guide provides a blueprint for breaking that cycle and fixing the system itself. We'll walk through a practical playbook for implementation, giving you the plans, metrics, and checklists you need to build a robust quality program from the ground up. More than that, you'll gain the insight to steer clear of common pitfalls and develop the ability to move from just talking about change to actually engineering it. Ready to dive in? Let's get started. So, have you seen this happen? A problem suddenly flares up, and a dedicated team scrambles to put out the fire. They work tirelessly, they fix the immediate issue, and everyone breathes a collective sigh of relief, right until the next fire erupts somewhere else in the organization. This cycle of reactive firefighting is not just tiring, it rarely leads to any kind of lasting improvement. To truly advance, you have to stop focusing on the smoke and start addressing the systemic issues that are causing the fires in the first place. This demands a fundamental shift in thinking. You have to stop seeing your organization as a collection of separate functions and start seeing it as a single, interconnected system. But how do you actually make that shift? Well, it begins by changing how you define and measure success. Many businesses concentrate on the cost of poor quality, calculating the expense of fixing defects after they happen. But there's a far more powerful method: measuring the cost of doing nothing different. This forces you to quantify the hidden expenses of inefficiency that are so often just accepted as the cost of doing business. Think of these hidden costs like an iceberg. The visible tip represents the direct failures you can easily see. But the true danger, the massive bulk of the iceberg, is submerged. It's the true cost of maintaining the status quo. By calculating this, you create a compelling, data-driven urgency for genuine change. Now, armed with this new financial perspective, you're ready to build a smarter measurement system. This is where the Integrated Enterprise Excellence, or IEE, framework enters the picture. Imagine looking at your organization from different altitudes. The satellite-level view provides the big picture, tracking high-level business metrics like profitability, market share, or return on investment. And here's the critical part. These are tracked over long periods, not just from one quarter to the next. Why? Because this helps you see the true, long-term performance of your business as a system and prevents you from overreacting to every short-term fluctuation. From that bird's eye perspective, you then descend to what's called the 30,000-foot level. This level focuses on the key operational processes that are actually driving those high-level satellite metrics. Here, you're tracking your value streams, things like production cycle time, customer wait time, or the time from order to delivery. By using control charts, you can clearly see which processes are stable and predictable, and which ones are failing to perform at the level you need. And this is where things get really powerful. This cascading system of measurement creates incredible momentum for improvement because the data itself points to where the real problems are. So, when a 30,000-foot level metric is underperforming, the person in charge of that process has concrete data to justify a Six Sigma project, and they already know it's aligned with the company's overall strategy. You've created an environment where everyone is working on the right things, for the right reasons. This foundation is your starting point. But to act on these insights, you first have to be sure the data you're collecting at the ground level is telling you the truth. This philosophy of seeing your business as a complete system is useless if the very instruments you use to measure it are flawed. To get ahead, you have to challenge the metrics you use, because what you measure ultimately determines how you react. Picture a typical factory floor. Let's say a measurement comes in at 78.2. Just a hair outside the upper specification limit of 78. A manager yells, "Joe, go fix the problem." Joe makes an adjustment, and the next few readings are back within range. Hours later, a reading of 71.8 comes in, below the lower limit of 72. Now the call is, "Mary, you fix it." This continues all day. But here's the thing, when you plot all that data over time, you realize that nothing has actually changed. The process is stable, producing a consistent pattern of variation. The managers were just reacting to the inherent noise of the system, something called common cause variation. By constantly tweaking the process in response to this noise, they were likely making things worse, not better. So how do you break out of this destructive cycle? You have to learn to separate the signal from the noise. The IEE framework does this with the 30,000-foot level control chart. Instead of taking lots of samples in a short time frame, you use infrequent sampling, perhaps one random sample per day or per week. This approach is so effective because the longer time between samples naturally captures all the routine, day-to-day noise, different operators, different batches of material, within the control limits. But these limits are calculated from the process's own variability, not from arbitrary targets. This gives you a high-level view of your process's true performance. When a data point falls outside these wide limits, you know you've found a genuine signal, a special cause, that needs to be investigated. And when the process is stable but still not meeting customer needs, you know you have a systemic problem that requires improving the entire process. This smarter way of measuring reveals deep flaws in many common industry practices. Take the acceptable quality level, or AQL, a standard method for inspecting batches. An AQL of 1% sounds pretty good, doesn't it? But the statistics often show that a batch would have to be 3 or 4% defective just to have a 50-50 chance of being rejected. It's a system that provides a false sense of security while consistently letting poor quality slip through. So now you have a reliable baseline. The next step is to have a structured method for acting on what you see. That method is the DMAIC roadmap, a 5-stage process that serves as the engine for systematic improvement. Instead of thinking of it as a set of rigid rules, picture DMAIC as a logical narrative that guides a team from a vaguely defined problem to a controlled, sustainable solution. It transforms the often chaotic art of problem solving into a replicable science. Your journey starts when you define the destination. In this first phase, you create a project charter that does more than just state a problem. It explicitly links that problem to a high-level business goal. This charter becomes your map, ensuring the team, management, and stakeholders are all on the same page from day one. Next, the measure phase establishes your starting point. Remember that 30,000-foot level control chart? This is where you use it to create a stable, trustworthy picture of your process's current reality before you try to change anything. You'll map the process, gather insights from the organization, and, this is crucial, conduct an analysis to ensure the data you're collecting is actually accurate. With a clear starting point, you enter the analyze phase, a period of passive investigation. Your goal here is to sift through all the potential causes you've identified to find the vital few that are truly driving your process's performance. You're not changing anything just yet. You're using graphical tools and statistical tests to analyze existing data. This is where you separate fact from opinion, allowing you to move forward with confidence. This leads you straight to the improve phase, where you shift from passive analysis to proactive testing. This is where the real breakthroughs happen. You'll use powerful tools like design of experiments to systematically test different settings for those vital few inputs you just identified, helping you find the optimal combination that will boost performance and reduce variability. We'll touch on this more in just a moment. Once the best solution is verified, the final control phase ensures the gains are permanent. This isn't just about writing a new procedure, it's about implementing robust controls. Often, you'll shift your monitoring from the final output, a lagging indicator, to the key process inputs themselves, which are leading indicators. By controlling the inputs, you prevent the process from ever drifting back to its old ways. While every stage of this journey matters, it's often in that improve phase where the most transformative discoveries are made, thanks to the power of structured, proactive experimentation. Let's explore why that is so revolutionary. To truly create a breakthrough with the DMAIC roadmap, you have to intentionally interfere with your process to see what it's really capable of. The single most powerful tool for this is the design of experiments, or DO. It's a method that fundamentally changes how you solve problems, moving you from inefficient guesswork to structured, rapid learning. To grasp its power, think about the traditional way most people try to fix things, one factor at a time. Imagine an engineer trying to improve a process, who suspects that both bake temperature and a chemical additive are important. First, they hold the temperature constant and increase the additive, but the result gets worse. So they go back to the original additive level and increase the temperature. This time, the result improves slightly. The logical conclusion seems to be that high temperature and a low additive percentage is the best combination. But here's the problem. This one-at-a-time approach feels methodical, but it's dangerously flawed. It can cause you to completely miss the most important discoveries. What the engineer didn't test was the combination of high temperature and high additive percentage. Had they done so, they might have found a result that was dramatically better than any of the others. Why? Because factors can interact. The effect of the temperature might depend entirely on the level of the additive. One-at-a-time testing is completely blind to these critical interactions. Design of experiments solves this problem by testing multiple factors simultaneously in a structured way. Instead of dozens of individual tests, a well-designed experiment can evaluate many variables, maybe 7 or more, in as few as 8 to 16 trials. It saves tremendous time and resources, and it's the only way to uncover those crucial interactions between variables that drive the most significant improvements. And this approach isn't just for manufacturing, its principles are universal. Imagine a school district wanting to reduce student absenteeism. Instead of trying one initiative after another, they could use a DO. The factors might be the day of the week, whether to implement parent callbacks, and which schools to test in. By testing different combinations, the district might discover a powerful interaction. Perhaps the callback program is wildly effective at reducing Friday absenteeism but has almost no effect on Mondays. This is an insight that would be nearly impossible to find any other way. Mastering a tool this powerful is a major step, but the ultimate goal is to embed this kind of structured thinking into your organization's very culture, creating a system that learns, adapts, and improves continuously. Building a system where structured thinking becomes second nature is where the real magic happens. You've mastered breakthrough tools like DO, but now comes the next chapter. Weaving this entire philosophy into the fabric of your company, creating a single, cohesive strategy for continuous improvement that aligns and enhances all your business initiatives. So what does this integrated system actually do? Well, it makes everything you do smarter. Take the way it seamlessly blends Six Sigma with lean principles. Six Sigma reduces variation and eliminates defects, while lean improves process flow by eliminating waste. The IEE framework provides the overarching measurement system that tells you which tool to use and when. If your charts show a process with low variation that runs too slowly, that's a clear signal to apply lean tools. Conversely, if a process is fast but inconsistent, that's a classic problem of variation, signaling the need for the structured DMAIC journey. As your organization matures in this way of thinking, your focus naturally shifts from fixing existing problems to preventing them from ever occurring. This is where design for Six Sigma, or DFSS, comes into play. While DMAIC improves existing processes, DFSS uses the same data-driven principles to design new products and services that are high quality and defect-free from the very start. What you're really creating here is a learning organization, a business that uses data to constantly challenge assumptions and recognize new opportunities. This represents a true cultural transformation. Leaders stop managing by reacting to numbers and start leading by improving the system. The central question shifts from, "Why didn't you hit your target?" to, "What is the status of the improvement project for that process?" Think about how different that feels. Instead of a monthly blame game where managers scramble to explain why they missed their numbers, you have productive conversations about system improvements. Instead of rewarding heroic firefighting, prevention becomes the hero's journey. In this guide to implementing Six Sigma by Forrest W. Breyfogle III, you've learned that the most effective way to improve any organization is to stop the exhausting cycle of daily firefighting. The solution is to adopt an integrated system that uses clear, high-level metrics to drive structured projects, solve problems at their roots, and create a culture of continuous, proactive improvement. That's all for this summary. We hope you found these lessons valuable. Thanks for listening.